Hello, Math Studies students, and welcome to your online lesson. Today we'll be continuing with factoring quadratic equations, but this time we will have an A-term value, and our goal is to efficiently factor quadratics to create two binomials. So a reminder, quadratic equation has an x squared in it. It's the most important part of a quadratic because that is what defines it. If it's an equation, it should have an equal sign. If it's an expression, it will have no equal sign. Today, once again, we are going to be looking at quadratics that have an a value that isn't 1. Everything that we've looked at before has just been x squared plus a bx plus a c. Now we are going to actually have things like 2x squared or 5x squared or things like that. Again, factoring can be called factorizing. Our goal is to get it into a pair of binomials. We first need to talk today about something known as monomial factoring. Well, you've heard the word binomial in some of our previous lessons, and we just said on the last slide that our goal is to turn quadratics into binomials when we factor. And a binomial, as we've seen in most of our factored answers, are things like x plus 2. Bi, because there's two terms that can't be combined together, an x term and a constant term. So bi. Monomial, like mono, is a single thing. So what we want to do is we want to talk about pulling out a single term out of a quadratic expression. And this can be done when there is no c term value or constant present in the quadratic, such as the following. So here we would have our x squared term with an a or without an a, and then we have our x term, which has the b in front of it, so our b, and then normally we'd have this plus c, which is just a number with no x. But when there's no c term, we can do something known as monomial factoring, where we just pull out a single term. So let's look at a couple examples of monomial factoring. And again, this is actual factoring when there's no c value. So on our first one here, we have two terms, 6x squared plus 4x. The question is this a quadratic here in part A? Well, does it have an x squared? Yes, it does. Is that the biggest power of any x that we have here? And that's absolutely true. There's just an x to the first power and then nothing else. So what we want to look at is these two terms that we have here, the 6x squared and the positive 4x. Is there anything that they have in common, a common factor, something that I could divide evenly out of both of those? And they're both even. So I know that I could pull at least a 2 out of both of those terms. So that's what I'm going to do. I'm going to pull a 2 out. And if I take this 6 here and I divide it by 2, what's left over? Or another way to say it is, what can I multiply 2 by that'll get us back to this 6? Well, 2 times 3 would get me back to that 6. And then I can do the same thing with this 4 here. 2 goes into that. How many times does 2 go into it? 2 times. Now, is there anything else that I can pull out? Well, each of these terms have an x. One of them has an x squared, which is really x times x. So they have at least one x that I can pull out. So I'm going to pull out an x as well. And then with the 6x squared, it was x times x. So I pulled out one of those x's, but there's still going to be a single x left. So even if I pull one of them out, there's still this other x that's going to be left there. So I would have a 3x. Everything was positive, so I'm going to put a plus sign. And since I pulled out this x, again, there's an x here, I pulled it out, so now it's hanging out front, and there's no x left. So I have done a monomial factor here. I have pulled out everything that was common between the 6x squared and the 4x. Now we can check our work by doing a little bit of FOIL. So I'm going to multiply this 2x times the first term, the 3x, and times the second term, the 2. Well, 2 times 3 gives me 6, and x times the x gives me x squared. So I have 6x squared. And then I'm going to do that 2 again, the 2x times the 2 here. And so I have 2 times 2, which is 4. There's no x's to be multiplied other than the one that was originally there, so we have 4x. And that gets us back to where we started. So in blue, this was the check, but my original monomial factor was everything I had in red here. So let me rewrite that one more time. Again, walking us through what's in common here. Well, they're both even, and 2 is the largest number that can go in, and they both have at least a single power of x, so I can pull that out. What's left behind? There was a 3 and an x for the first term, and a 2 here. Now let's move on to part B. Part B, we have 3x squared minus 12x. So what do they have in common? Well, I know a 3 will go into a 12, and obviously it goes into itself as well. So I can pull out a 3. Do they both have at least a single x getting multiplied? Well, this one has x times x because it's x squared, and the other one has this single x here. So I can definitely pull out an x from each one of these. There'll still be an x left behind in the first one, but there won't be any x's left behind in this second term. So what do we have now? In the first term, we pulled out one of these x's, so there's one x left behind. So I have one x left behind. The 3 got pulled out, so there's no coefficient or number in front of it. Then we had a negative 12x. We already pulled out the x, and we pulled out a 3. So what times 3 gives me negative 12? And that answer is negative 4. And that would be monomial factoring. Again, I can check my work by multiplying here, and I would get 3x squared when I multiply 3x times x, and 3 times negative 4 gives me negative 12, but the 3 was with an x, so I have negative 12x, which is the same thing that we had up there. So it definitely checks out. One more quick example here, looking at this last one. Now 2 and 5, they're both prime numbers. Nothing goes into them except for themselves and 1. And so 5 isn't even, so I can't even pull a 2 out of it. So there's nothing as far as integers or numbers that I can pull out. But they do at least all have an x. So I'm going to pull out an x and then see what's left behind. So I had 2x squared as my first term, but I pulled out one of those x's. So I'm literally just sort of subtracting one of those exponents away. So now I just have 2x. And then finally, plus 5x, but I already pulled the x out, so it's just plus 5. And if I distribute that x again, I'm going to end up with 2x squared plus 5x. So once again, it all checks out. So that's monomial factoring. Again, we can do monomial factoring anytime we have a quadratic with no c term. So now getting on to the main part of our lesson today, we're going to be talking about factoring quadratics with an a value, meaning that there's going to be a number in front of x squared. And we have not seen that up to this point when we were doing our factoring. So the first thing you have to do is check to make sure it has an a value. And if so, we're going to use these steps rather than the steps that we looked at in the last couple of videos. So we're going to multiply the a and c terms. So you'll get this new product. Product is an answer to a multiplication problem, AC. So you'll have a new number. Again, you're multiplying the a and the c together. After that, we are going to find the factors that multiply to equal AC. Different numbers that we can multiply together to equals AC. Very similar to what we did when we were doing the other factoring without an a term, where we'd find the factors of the c term. Now we're finding the factors of a times c. And again, we want to check which of those factors will add to equal b. And that's kind of the same thing we did before. Again, there's the one extra step here where we're multiplying the a and c first rather than just looking at c. Then we're going to rewrite the original quadratic, replacing or splitting the bx term. And I'm going to have to show you that with an example. But basically, this b term, we're going to split it apart and write it as two separate terms, each with an x. All right, so we'll look at that in a little bit. And then finally, and this is why we reviewed this on the last slide, monomial factors. We're going to pull out a monomial factor from the first two terms and then also the last two terms. And there's going to be 4 terms because we'll have split the b in step 4. Finally, group the monomial factors to create a single binomial. So the things that you pulled out will go together. And then whatever's left over from each of our first 2 terms and then from our second 2 terms will be our second binomial. And they should be identical. And we'll take a look at that in just a moment. So again, feel free to pause this slide and copy all these notes down. These steps will make more sense when we're actually looking at a problem, which we're going to do right now. So starting with our steps, the first thing, does it have an a term? Yes, it does. So we can't just list the factors of our c, because normally what we would have done is just say, okay, we have a negative 10. What things multiply to be negative 10? 1 and 10. Check which one's positive, which one's negative, all that sort of stuff. But we're not doing that. The first thing that we're going to do now is we are going to multiply our a and our c terms, since we have an a value that is not just 1. It's 6 in this case. So our a times our c, this a right here, times this c right here, and keeping the signs with them, gives us negative 60. All right, now we're going to list the factors of negative 60. So I've got a 1 and a 60. I'm not going to worry about the sign just yet. I've got a 2 and a 30. I've got a 3 and a 20. 4 and 15. 5 goes into it 12 times. 6 goes into it 10 times. 7 does not go in evenly. 8 does not go in evenly. 9 does not go in evenly. And then that leaves me back with 10, which we already have here. So I don't need to go any further. Now, I was dealing with these large numbers. If you're ever unsure, again, just take the calculator and take 60 divided by, and whatever number you're checking, divided by 3, for example, divided by 6, for example, divided by 8, the ones that weren't working. If you get back a whole number, it's got factors. If not, it doesn't. All right, and so we want things that multiply to be negative, but we know the bigger of these should be a negative, a positive value, because they're going to have a b term that is positive, and we want these to add together to be positive. So I'm going to put the negative sign on all these smaller ones because I want them to add together to be a big term. Now, obviously, if I add together 60 and negative 1, I'm going to end up with 59, which is way too big. And so I'm going to save myself a little trouble, and I'm going to jump down here where the numbers are a little closer together. And I have 10 and a negative 6. I'm going to add those together, and I get positive 4. And lo and behold, that's what we had here. So same steps we were doing before, except we had that extra thing where we did the a times the c rather than just listing the factors of the c. Now, if you'll remember before, our a's were always 1. So really, you could have thought of it that way as well. But here we have this a term of 6. So now what I'm going to do is I'm going to take this negative 6 and 10 that we decided did add to be our b term, and I'm going to split the b term. You don't have to write these arrows, but I'm going to show you what I'm doing. So I'm bringing just down that 6x squared, my a term. I'm going to bring down my c term, but now the 4x, I'm just going to rewrite as negative 6x plus 10x. So I'm just writing the exact same thing down because I know 10 plus negative 6 does get me back to this positive 4 here. So I haven't changed the meaning, I've just broken it apart. And a lot of people will call this method here that we're doing the bucket method, because I will often put a little bucket, if you will, or a way to group these. I don't want to put parentheses, but I'm going to put a little something below that. And now out of each of those first two terms, I want to say, what do they have in common? What could I factor out? And both of these, looking at this 6x squared and this negative 6x, they both have a 6 in common that I can pull out, and they both have at least one x that I can pull out. Now, what's left over? So now it's like our previous examples where we're doing monomial factoring. Well, I pulled out the 6. I pulled out one of these x's from the x squared, leaving a single x behind. And now if I pull a 6x out of negative 6x, well, all the 6x is gone. So 6x times what would equal 6x? Just 1. But I need it to be negative, so it must be a negative 1. Now I'm going to go to this second group that we have here, the 10x minus 10. And what do they have in common? Well, they clearly have a 10 in common, and that's about it. The first one has an x, the second one doesn't. The second one's negative. So again, you could check that. 10 times x gives me 10x, and 10 times negative 1 gives me negative 10. So I've done it. I've pulled out my monomial factor. We're not quite done. We have one step left to go. We're going to take the two things that we pulled out as our monomial factors and make a binomial out of them. 6x plus 10. And then what's left over, which is this x minus 1 in parentheses and this x minus 1 in parentheses, well, what was happening to those? The first one was getting multiplied by the 6x. The second one was getting multiplied by the 10. Well, now we've put those together in this sort of super binomial, 6x plus 10, and of course they're multiplying by x minus 1. So all I did was take these redundant binomials, x minus 1, and I just made a single one of them there. And my other binomial came from the things that I pulled out. Of course, we can go ahead and check this work by distributing. We distribute here, we get 6x squared. Do 6x here, we get minus 6x. Distribute our 10 to each of those terms. We have a plus 10x and then minus 10. And you'll notice that's actually this step right here. And then when we combine these middle terms, we'll be back to 4x. All right. Speedy check, but I want to get to one more example here in this video. Keep it from getting too long. All right, so factor the following quadratic expression. Again, there is an a term, so our first step is to multiply the a and the c term, which gets us to negative 12. Remember to keep the sign of that c term. It's a negative 3. Now I'm listing my factors, so I've got 1 and 12, 2 and 6, 3 and 4, and that's it. We know that one of them has to be negative because my c term is negative, but the bigger one has to be positive because my b term is positive. So I'm going to make each of these negative here. add them together, I get 11, I get 4, and I get 1. You might say, well, none of those are my b term, but remember, there's just a single x here, so it's like 1. So these are the values I'm going to use. So I'm going to split apart my b again, splitting it apart. So we're going to have 4x squared. And then the b is going to get split into negative 3x plus 4x. Remember to take these factors and put an x with each of them. And again, that's what this guy is going to split apart to become. Remember, if you check it, negative 3 plus 4 will still get me back to that 1. And then bring down your c term, minus 3. Now we're going to do those buckets. We're going to group them and look for monomial factors. So I have 4x squared minus 3x. What do they have in common? Well, 4 and 3 do not have any common factors, so I can't pull anything out of that. But they each have at least one x. So I'll pull an x out. So that leaves me with 4x for my first term. It used to be squared, but I pulled one of those x's out. And then minus 3. Again, it used to have an x, but I've already pulled that x out right there. All right, go on to our next one. I have 4x minus 3. What can I pull out? Nothing. So I pull out a 1. Meaning, what number could I multiply by a 4x that turns it into a 4x? 1. What number could I multiply by a negative 3 that turns into a negative 3? 1. Now, that seemed like we didn't really do much, but if you look here, we've pulled out a monomial factor from each of those. So I have x plus 1. I can put them together as a binomial. And then, lo and behold, the leftover binomials are the same, which is our goal. And if they're the same, we did it correctly. And those are our factors for this quadratic. All right. I did have one more example ready to go, but since I've already crossed the 15-minute mark by almost 2 minutes at this point, I will not do that here, but I will put the example up. I have 2x squared plus 5x minus 12. And if you're looking for a little more practice, feel free to try that one on your own. Otherwise, we will see you next time. I hope you enjoyed this video on factoring quadratic equations with an a-term value. We've now looked at all the types of quadratics we need to handle, and we'll get eventually to solving them. Till next time.